these salts. And why salt is so important is it tells us that it's strong evidence for a liquid source for the plumes, perhaps even a liquid ocean underneath them. And so the detection of sodium is very important in that way, and saying that the source is possibly a liquid. And the other very interesting find was the detection of ammonia, that the ion and neutral mass spectrometer basically was on during our flyby through the plumes. It could sniff out the chemicals that were part of the plumes, and they found organics, water, of course, and then strong evidence for ammonia. And you might say, well, why is ammonia, so interesting? And in part, what it is ammonia dissolves in water, and it acts as a really great antifreeze. And so you can, with ammonia in the water, it can be in a liquid state down to something like minus 143 degrees Fahrenheit. And so that tells us that another piece of evidence that source for the plumes could be liquid water.
More from Cassini Deputy Project Scientist Linda Spilker in a minute. This is Planetary Radio.
Hey, Bill Nye, the science guy here. I hope you're enjoying Planetary Radio. We put a lot of work into this show and all our other great Planetary Society projects. I've been a member since the disco era. Now I'm the Society's vice president. And you may well ask, why do we go to all this trouble? Simple. We believe in the PB&J, the passion, beauty, and joy of space exploration. You probably do too, or you wouldn't be listening. Of course, you can do more than just listen. You can become part of the action, helping us fly solar sails, discover new planets, and search for extraterrestrial intelligence and life elsewhere in the universe. Here's how to find out more.
You can learn more about the Planetary Society at our website, planetary.org/radio, or by calling 1-800-9-WORLDS. Planetary Radio listeners who aren't yet members can join and receive a Planetary Radio t-shirt. Members receive the internationally acclaimed Planetary Report magazine. That's planetary.org/radio. The Planetary Society, exploring new worlds.
Welcome back to Planetary Radio. I'm Matt Kaplan. Linda Spilker of the Cassini Equinox mission is giving us another update on what that spacecraft has taught us about the Saturnian system, including Enceladus, the moon that shoots towering water geysers out into space. Is it getting easier to understand how this little moon that everybody thought was too small for any of this could have all this wet activity?
It's still a puzzle how a moon this size, that's so small that we think should have been frozen solid by now, could have this much activity going on. The process by which it's got started and keeps going is something that we're still trying to figure out. And we hope as we get more close flybys, we have a couple of more dives into the plume in November, that perhaps we'll get more pieces to this puzzle that's Enceladus.
Let's turn now to Titan. I'm sorry to say that I can't remember who I'm getting this quote from, but somebody just recently, I heard, called Titan, at least geologically, the most similar body to our own, to Earth, in our solar system. Do you agree?
Yes, it's similar in the sense that Titan is one of the few places where you have a liquid. In this case, it's liquid methane, or like the gas in your stove, that can be a liquid, a solid, and a gas. And so it works on the same way on Titan's surface as water does here on the Earth. So you can form methane clouds, they can rain out, they fill lakes on Titan, create river channels, and very, very similar to the processes we see, the erosional processes we see on the Earth. So the temperatures are quite different. It's very much colder on Titan, but many of the processes between Titan and the Earth are very similar.
It's so fascinating that all of these phenomena can be so similar, and yet they're offset by hundreds of temperature degrees, just working with a different fluid. And to the point where the similarities now apparently even extend to storms.
Right. In fact, a recent paper came out that there was a huge storm. It actually was back in April of 2008. Detected from the ground. It turned out that this storm formed and dissipated between two of Cassini's close flybys of Titan. And this storm was in the dry equatorial region, and it's fascinating because, first of all, it was a large storm, which they don't appear to happen too often. And then second, to have something in these dry latitudes, you'd need some process to raise the humidity of methane. In other words, some injection of methane into the atmosphere, perhaps. Maybe a cryovolcano, so you have both heat and the methane coming out to create this huge convective cloud, this convective storm that sprang up near the equatorial region on Titan, or it could be something else that we haven't even thought of yet. So it was very exciting to see this cloud, and in fact, given the rare occurrence of clouds with Cassini, we've made a change in our program. We're now trying once or twice a week to go back and take some pictures of Titan, just because that it can be a very long time between our close flybys with Cassini, and we want to make sure not to miss anything.
Okay, so what's next, other than these results to look forward to from Cassini's studies during the equinox period?
Well, we have a couple of close Enceladus flybys coming up in November, and so that'll be very exciting. And we continue to have additional Titan flybys every 2 or 3 weeks or so. And so it'll be interesting to see if we see any more cloud activity or changes in the weather now that we've passed through equinox, and as the sun starts to shine at the North Pole of Titan. That's the place where we've seen all of these methane lakes with ethane inside of them. Will these lakes start to evaporate, perhaps, as the sun starts shining more and more at the North Pole? And will we see perhaps more weather as the seasons change on Titan?
Any of those upcoming Enceladus flybys going to be those very low ones, possibly right through those plumes?
Yes, that's the plan. It's basically to skim through those plumes and continue to make measurements about their composition.
Just one more. How about down there on the big planet? Is anybody watching for changes in, for lack of a better term, the weather, as the planet also passes through the equinox?
Yeah, for looking at Saturn, this is a great time because with the sun essentially edge on with the rings, as you can imagine, the rings cast their smallest shadow ever on Saturn, and so you have a great view of both the northern and southern hemispheres of Saturn, and so it'll be a good chance to observe the clouds and the weather on the planet as well.
Linda, it's always a pleasure, especially when you make the trip in spite of the fact that the one of those famous L.A. brush fires is burning right there in the hills above JPL.
Right, yeah, the La Cañada fire. I was keeping an eye on as I came in today, and I could see these great large clouds of smoke coming up, and fortunately it looks like the wind's sort of blowing north, so it's not blowing the smoke in the direction of JPL. Okay,
we don't want any interruption in data collecting for Cassini or any of the other missions there at JPL, and still figuring out how to get Spirit out of that sand trap too. So hang in there, and good luck to all of you on the Cassini mission, and I look forward to checking back with you again.
Okay, great. Thanks a lot, Matt.
Linda Spilker is the Deputy Project Scientist on the Cassini mission. She's been with that mission for, I think since she was about 8 years old, right, Linda?
No, not quite, but for a long time, since well before launch.
Anyway, it is Cassini, and it is the Equinox mission now, of course, the extended mission of that great spacecraft that continues to explore that amazing Saturnian system right in our own backyard, right here in the solar system. We'll take another look at that solar system and beyond when Bruce Betts is visiting with us for this week's edition of What's Up. That's after we hear from Emily.
Hi, I'm Emily Lakdawalla with questions and answers. A listener asked, how could an asteroid make such a big mark on Jupiter when it doesn't have a solid surface to make a crater in? When a small object smashed into Jupiter on July 19, 2009, it left a dark mark near the giant planet's south pole. The mark was the size of Earth, yet the object that hit Jupiter was likely only around a kilometer across. How could such a tiny body make a big mark in a gassy planet? To understand the answer, you need to know what happens when an asteroid comes in for a crash. First of all, it arrives at an incredibly high speed, about 100 kilometers a second. The impact speed is much faster for Jupiter than for Earth because Jupiter's gargantuan gravity accelerates incoming bodies to much higher speeds. As the rock rockets downward, it compresses the gas in front of it. Just as a bicycle pump heats when you use it to compress Earth's air, the air in front of the asteroid heats, but because the speed is so high, the pressure is enormous and the air heats to thousands of degrees. Soon the rock explodes. It vaporizes, contributing its elements to Jupiter's clouds, but the huge planet hardly notices that. What it does notice is the splash. Fiery hot gases fly in all directions from the impact, especially upward through the transient hole left in the atmosphere by the incoming fireball. This